The last alcohol reaction that we have is a combustion reaction. And in this combustion reaction, you should remember how to do this from last chapter or from previous examples. But anytime you have the carbons and hydrogens, you can burn them. It doesn't really matter if you add that oxygen in there. In fact, that actually adds fuel to the fire. It's easier to combust an alcohol than an alkane, right? They're even more flammable. So all I'm going to do is make the same products I did before. So I'm going to have carbon with oxygen, some carbon dioxide. I'm going to have a water product. But this time it's going to balance a little bit differently. So it's going to be a little confusing at first, but you just kind of have to figure it out. So my alcohol over here, right, first I got to figure out, okay, there's 2 carbons in this ethanol, but there would be 3, 4, 5 hydrogens connected to carbons, but then there's also another hydrogen in that hydroxyl group. So if this is my formula here for that alcohol, C2H5OH, right? In reality, there are 6 hydrogens there, right? And I'm going to react it and try and balance all this stuff appropriately. Remember, I'm supposed to balance the water first, right? And in this case, I have 6 hydrogens in my ethanol. So I'm going to need 3 waters over here. And last chapter, I told you, as soon as you see an odd number in front of a water, you should have warning bells going off in your head telling you that I can't do this, right? It's not going to balance. But actually, this chapter, that's a good thing, right? Having an odd number of oxygens on the right isn't going to be that big of a deal, because when it's all said and done here, I'm going to have, right, let's balance the rest of this. 2 carbon dioxides, 3 waters, and between those 2 products, I'm going to have 7 oxygens. Makes it look like a 70, right? So 7 oxygens. But on the left, I need 7 oxygens. All I have to do is realize that before I balance the oxygens, before I put any number in here, I need to recognize that there's at least 1 oxygen in that ethanol over there. So I actually have to subtract 1 from the 7 before I divide by 2, in which case I'm good to go, right? I didn't have to do anything special to balance this because I want an odd number of oxygens because I'm going to need an odd number of oxygens at the end of the day. So an odd number of waters is not a problem in this case, right? There's 7 oxygens on both sides when this is balanced. So like I said, biggest problem is balancing this, trying to figure out what your formula is for that ethanol, and then recognizing that I want an odd number of waters instead of an even number of waters. So I can burn that ethanol. I can also burn this isopropyl alcohol, that rubbing alcohol, and this one's going to look a little bit different, right? So once again, same 2 products. And in both cases, just like before, you can throw that energy in there because that's actually the point, right? So when I'm burning this time I have 3 carbons. So I would have 8 hydrogens, and I still do in reality, but I have 7 hydrogens that are connected to the carbons, and then a hydroxyl group. Right? That's my formula for that alcohol, for my isopropyl alcohol there. And again, 8 hydrogens total. That means I should have 4 waters over here. Now, this is the example when I need warning bells to be going off in your head. I can't have an even number of waters and make this balance. It's just not going to work. So what that should tell you right away is that I should actually double, right, the amount of alcohol molecules I have reacting here. I should change that 4 to an 8, right? I now have 6 carbons on the left, so I need 6 carbons on the right. That's going to give me, what is that, 20 oxygens on the right. But now, again, I subtract 2 from the 2 alcohols, and I get an 18, and then I can divide by 2, and that's going to give me a 9, right? So this time I needed to double it to make it happen, right? It wasn't possible to make the left side even until you doubled it. So the real problem here is that since I have a singleton oxygen over here, and I have a singleton oxygen over here, right? If one of those is odd, both of them have to be odd, right? So if you look up above, right, I have the singleton oxygen with 3 of them. I have a single here, and it is an odd number. There's one of those. That's perfectly fine. That's what I'm supposed to have, right? But if I have an even number for either one of those 2 things, that's when I'm going to run into a problem. They either have to both be odd or both be even to get this to balance. So again, hopefully that's not too confusing, but when you burn your alcohols, you have to recognize there's an oxygen in the alcohol itself. That becomes part of your products, and it makes it a little bit harder to balance. So I'm not looking for odds that I need to double. I'm looking for an even number of waters that I need to double. Right? It's just going to be kind of a flip from what we did before. Right? Obviously, in these cases, there would typically be I'd have to have a little spark to make that go, right? I'm going to need that heat to make this combustion happen. But again, these are even more flammable than our alkanes from before. So it shouldn't take much, right? They'll spark pretty fast. So I would have a catalyst there. I just didn't know how to make that on the Promethean board, aside from drawing it myself. So look for the catalyst. It would need to be there. But otherwise, balance it appropriately, and we should be fine.